video, we will learn about tuned amplifier. On completion, students will be able to design and analyze the performance of different tuned amplifier. C. Tuned amplifier. During a Class C amplifier operation, the collector flows for less than half cycle of AC signal. A Class C amplifier is biased for operation for less than 180 of the input signal cycle and its value is 80 to 120. Less than 180 means less than 50% and would operate only with a tuned or resonant circuit, which provide a full cycle of operation for tuned or resonant frequency. Because the collector voltage is not a replica of the input, the resistively load classic amplifier alone is of no value in linear applications. If it is therefore necessary to use a Class C amplifier with a parallel resonant circuit or tank circuit. The short pulse of collector current on each cycle of the input initiates and sustains the oscillation of the tank circuit so that an output sinusoidal voltage is produced. The tank circuit has high impedance only near the resonant frequencies, so the gain is large only at this frequency. In tuned RF amplifiers, transistors are used at the frequencies nearer to their unity gain bandwidth to amplify a narrow band of high frequencies centered around a radio frequency. At this frequency, the interjunction capacitance between base and collector CBC of the transistor become dominant. That is, its reactance become low enough to be considered, which is otherwise infinite to be neglected as open circuit. Hazelton introduced a circuit in which the troublesome effect of the collector to base capacitance of the transistor was neutralized by introducing a signal which cancels the signal coupled through the collector to base capacitance. He proved that the neutralization can be achieved by deliberately feeding back a portion of the output signal to the input in such a way that it has the same amplitude as the unwanted feedback but the opposite phase. The figure shows one variation of Hazelton circuit. In this circuit, a small value of variable capacitance Cn is connected from the bottom of coil point B to the base. Therefore, the internal capacitance CBC shown dotted feeds to a signal from the top end to the coil point A to the transistor base, and Cn feeds a signal of equal magnitude but opposite polarity from the bottom of coil point B to the base. The neutralization capacitor Cn can be adjusted correctly to complete in nullifying the signal fed through the CBC. The figure shows typical neutron circuit. In this circuit, the neutralization capacitor is connected from the lower end of the base coil of the next stage to the base of the cap transistor. In principle, this circuit functions in the same manner as the Hazelton neutralization circuit, with the advantage that the neutralization capacitor does not have the supply voltage across it.